Today's video is how to find the area of regular polygons. These are probably the most challenging areas out of all of the basic shapes. So let's take a look at this one. So formula again is 1/2 SAN. S is the side length, A is the apothem, and N is the number of sides. We're going to take a look at 3 examples. This one we're going to work all the way through. The other two we're just going to take a look at what if you're given some other things. So first thing that you need to do is to draw a triangle from the center. And the triangle you need to draw looks like this. And the side here, this we would call the radius, because if you would draw a circle that goes around the outside of the shape, making it an inscribed shape, that would be the radius of that circle. The height of this triangle is the apothem, or A, and then the base of it is 1/2 of your side length. So realize this is 1/2 of S. So this whole thing is 10. So this new part would be 5 in this situation. So that's the first thing we need to do. Second thing we need to do is find the central angle. And to do that, what we're going to do is we're going to take a look. The whole distance around here is 360 degrees. So I'm going to take 360 degrees divided by the number of sides. And in this case, the number of sides is 8. It's an octagon. So I'm going to divide that by 8. So 360 divided by 8, then I'm going to divide it by 2 again. So I'm basically going to take 360 divided by 16. And that comes out to be 22.5. So the angle on the top right here is going to be 22.5 degrees. And that's the most important angle for us. So that's what we need to do. Draw a triangle from the center, find the central angle, and then from that point, we're going to have to use SOHCAHTOA to figure that out. So I'm going to redraw this little triangle over here so we have a little bit more space. This is 5. I need to find A. The R is not needed for the formula, so I'm not going to worry about that right now. My angle up here, once again, is 22.5 degrees. So I have enough information to figure out what A is because this is a right triangle. So I'm going to use SOHCAHTOA to figure that out. So each situation you come across, you're going to use a different part. You might use sine, cosine, tangent. So this one, I have the opposite side and the adjacent side. So I'm going to use TOA. So tangent, my angle goes next, 22.5 degrees, equals the opposite side, which is 5, over the apothem, which is A. I'm going to solve this for A. So if you remember this one, I always call this one the switch because you multiply A up to both sides and you divide back the tangent. So A is going to be 5 divided by tan 22.5. So if I plug this in to my calculator, first of all, make sure in your mode you are in degrees. And then I'm going to go 5 divided by the tangent of 22.5. And that gives me approximately 12.1. And in this case, the units are in meters. So I needed to go ahead and find that part of it. And now I know everything about this. I know S. S is 10. I know my A now, and I know the number of sides. I can go ahead and solve for the area of this shape. So the area is going to be 1/2 the side length, which is 10, times the apothem, which is 12.1, and the number of sides is 8. If you want to be a little bit more exact, we're going to use this number without rounding it until the very end. So if I just hit the times key on most calculators, you'll use the previous answer. So I'm going to multiply that by 0.5, which is my 1/2, times the side length, which was 10, and then times 8. And that will give me my area. And then at this point, I'm going to round it. So I'm going to get 482.8. and the units were meters. So we're talking meters, so that's going to be meters squared. So that's how we figured out if we have a side length. Let's take a look at two quick examples of how do we do it if we have a different portion. So in this one, if you'll notice, you're given this length and it goes to a point on your polygon. So remember, once again, this is the radius. So be very careful. Okay, if you're given the radius, then we need to draw a triangle that goes to the center of one of the sides, and that's what my triangle would look like. So if I drew this out, this 5 is going to be the hypotenuse of this triangle. So then we'd have to go back again and find out what the central angle is. So that's going to be 360 divided by the number of sides. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a decagon. And I'm going to divide that by 2. So 360 divided by 10 is 36. Divided by 2 is 18. So this is 18 degrees. And then I would have to figure out, am I using sine, cosine, or tangent? This one we actually have to find two parts. I have to find the apothem and the side length. And actually this is going to be 1/2 the side length when we're done. So you would do, to find S, I would use sine. So I do sine 18 equals opposite, which is S over 5. And then to find the other one, A is going to be cosine. So cosine 18 equals adjacent over hypotenuse. And you'd solve these out. But once again, realize that this S is only half of the entire side. So that's how you go about doing it if you're given a radius. Last example, what if you're given the apothem, but you're not given the rest of it? So same idea, we draw a triangle from the center, and we got to figure out this one. So I do 360 divided by the number of sides. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. So this is a decagon also. So divide that by 2. So this is once again going to be 18 degrees. And so if I go about doing this, then sketch my triangle a little bit easier to see here. So 12.3, 18 degrees. And this is 90. This time I would need to find the bottom, which is 1/2 of my S again. So this one is going to be tangent once again. So I'm going to do tangent 18 equals S over 12.5. And you would multiply your 12.5 up to solve for S. Once again, the S is only half of your actual side length here, so make sure you double that in your formula. So these are some examples of how to find the area of a regular polygon.